doesn't really explain anything, isn't it? So it just say it defines a contract. Now, we heard the word contract before when we create the abstract method, right? So what kind of contract that we made before when we create the abstract methods? So who are we making this contract with?
The parent class?
Yeah, the parent class with
Object?
the subclasses, right? So the parent class defines an abstract method. So you are creating a contract between the parent and the subclasses for the implementation. So anyone who wants to inherit from that class, they must sign the contract and says, I'm going to override or implement that method, right? So that is basically the contract that we talk about in the abstract methods. Now, an interface is actually a collection of abstract methods. And that is why it's a contract as well. Because it's the same thing as having abstract methods in your class. Now, what's the difference between what we did today with a class, and then the fields, the properties, the constructors, and the abstract method with an interface? An interface contains only abstract methods, and that's it. So an interface doesn't have fields, interface does not have properties, interface does not have constructors, and interface only contains abstract methods. Now, I'll show you the example here. So to create an interface, we are using the keyword interface. So that is a keyword that we use, and the name of that interface usually starts with the capital I. So that is a naming convention. Now, how many methods do we want to have in the interface? It's up to you. It could be one method or more than one method. So every single method that you declare here is going to become an abstract method by default. So you don't have to put the keyword abstract, and you don't have to put even public, because the default is a public access modifier. So that is the simplest way to declare your interface method. Now, so when we have an interface with one or more methods, what are we going to use that for? So the next part here is the implementation class that implements the interface. So you can implement the interface by overriding the method and put your own implementation here. Now, I'll give you one scenario. So this is going to be following up what we did today, right? So if I go back again to my example, so I look at my example here. Back to my parent class. Alright, so I look at this method here. So I declare the abstract method in the employee class, and this time I want it to imagine. What if I have more than two types of employees? So the next type of employee is the employee that doesn't get paid. So I have some volunteers who come into the employee to help us with a few tasks, and they do not get paid, right? Now, the question is, if I have that kind of employment in my company, what will happen when I create the volunteer class? Do I have to override this calc weekly pay, or I don't have to?
Yes.
I have to, that's right, because I created a contract by using abstract method, right? Now, is the design still correct? Do we still want to have an abstract method in the base class? Because you're creating a contract with all the subclasses that you must override that, right? So according to the new scenario, it's not correct anymore. So we want to make this method to be optional. You don't have to implement this in every single subclass. So how do we do that? By defining an interface. So with the interface, you can still create a contract, but you can apply the contract to some classes only. So it doesn't have to be to all the subclasses. Now, so watch this. I'm going to add the interface first. So let's add a new item, and then I can show the templates, and then choose an interface, and then specify the name of the interface. So I call this as iPay. So the interface name usually starts with capital I, right? Okay, so let's make that into a public interface, and then I'm going to move the method into my interface. So back again to the employee class, and this is going to be moved to the interface.
The interface is a class.
right? So that is an interface. So that is not a class. So interface only contains abstract methods. Yeah? Okay. Now, so in this case, by default, all the methods are public and abstract, so you don't have to use the two keywords anymore. So that is the simplest form of your interface methods. Yeah?
If you don't put the public keyword in or access level in line 9,
Mm-hmm.
does it still work?
Yes. So it's going to use the default access modifier.
Because it's public.
Yeah. So every single member that you define in the class or any other type of classes, interfaces, they all have their own default type, right? So default access modifier. Alright, so guys, so that is my example this time. Now, is everyone okay with the syntax? Yeah? So we can see the keyword is not a class this time, so that is an interface. And we have methods. So you can have multiple methods if you want, and these are all abstract methods. Now, so what I'm going to do this time, I'm going back again to my other classes. So let's start with the parent class. So the parent class only have one method. So the method here is get details. And then, if you have a look at my class again, this class does not contain any abstract method. So that means if I want to, I can remove this abstract keyword, can I? So that is not required anymore. You can remove that, and that is still a valid syntax because we don't have the abstract method anymore. Now, the question is again, do we want to remove that? Do we want to allow a generic type of employee to be created in the system, or we don't want that?
We probably don't want
We don't want that. Very good. So if we don't want that, we can keep the abstract keyword. So that means we cannot create the object of this class, right? So when you create an abstract class again, you cannot create the object of the class. It doesn't matter what you have inside the class here. So there could be abstract methods or no abstract methods. So that is just not to allow you to create the object of the class. Yeah? Okay. Does that make sense why we make that abstract? Yeah? Okay. Alright, so once we have done that, so the next thing that I'm going to do now is go back to my full-time employee and have a look at the syntax error. So this time, it doesn't know where's that coming from, right? So the contract is coming from the interface this time, not from the base class. So we need to implement the interface. So how do we implement the interface? The same way that we do inheritance. So after the column, we can specify the name of the interface that we want to implement. So if you have a class that you inherit and you also want to implement an interface, we just have to put a comma in order to separate them. So the one that I want to implement is my iPay interface. So that is basically my inheritance and my interface. Then have a look here. So what do we have to do this time? Now, so let's have a look again. So it says here, there is no method to override. So how do we implement an interface? So let's go back again to that previous example here. To implement the interface, we don't use the override keyword at all. So no need to use override. So I can get rid of that because we are not overriding the base class definition. So this is basically the solution. Now, back again and have a look here. So full-time employee is the subclass of employee, and full-time employee implements iPay interface. So what does that mean this time? Full-time employee will inherit all the members of the employee class. So all the fields, all of those methods from the employee class, and we're also going to get the behavior that is defined in the iPay interface. So you're adding methods, you're adding functionalities to the full-time employee class by using interfaces. So interface again is basically a collection of abstract methods, and that's it, right? Now, so why do you think is better to use interface in this example?
Because it allows you to make certain abstract methods optional across different classes.
Yeah, very So I'm going to do the same for the next subclass. So this is going to implement iPay, right? And then we change the declaration here. So no need to use the override keyword. Okay, so let's try to run it.
You could do this with virtual as well.
With virtual as well, very good, yeah. Now,
So there's no additional benefit.
very good. So let's talk about another scenario after this, right? Okay, so just to show you again, the output will still be the same. So we still have the ID, the name, and then the department name, right? So nothing changed at all. Now, there was a really good point there, Elsa. Sorry,
Let it go.
we have to stop singing now. So why do you think we don't use virtual method? What is the difference this time? Now, let's try to think about that again. If I create a method here to calculate the weekly pay, and it's a virtual method, right? So the virtual method must contain a definition. Is that right? Yeah? So how do we create a virtual method? For example, I'm going to create a virtual method to do the calculation. So this is going to be called a different name. So I call that as calc, and I haven't made that virtual yet. And this is just to show you what that looks like. Okay, so return 0, for example. And if I want to allow that method to be overridden in the subclass, I can use the virtual keyword. Remember that? Yeah? Okay, so what is virtual again?
Option.
Yep, option. So you can override the method in the subclass, but you don't have to, right? So where we have virtual, you must have the method definition. We cannot just leave it like this. That is incomplete. For virtual must have method definition. So abstract does not have method definition. So that is a difference. Now, so one of the things that you're going to notice straight away, you're going to see that this method here must have an implementation. So you must add some logic into that. So is that the correct logic or not? So that is one consideration, right? And then, if you are creating a method in the base class, which methods can create or implement that? So which classes can implement the methods that you declare in the base class? Only the subclasses,
Yeah.
the child classes. But what if I have other classes that must do the same calculation, weekly pay? Do I make inheritance from that class?
No.
Or I don't make inheritance? Because when you start creating inheritance, remember we talked about the issues before. You might have too many members and they're all not required, right? Now, I'll give you one scenario in this case. Imagine if that calculate weekly pay is still in the base class here, not in the interface. And have a look at the purpose of the method again. So the purpose of the method is to calculate the weekly pay, right? So if I don't have only employees, let's say I have different type of people that needs to get paid as well. So I can call them as contractors, for example. So I don't want to make my contractor as an employee in that case. So what do I have to do in order to be able to get them paid? Do I make my contractor to inherit from the employee class if you're using abstract method? But the relationship will be incorrect because contractor doesn't have employee ID. So we can't do that anymore, right? So this is the time when interface will be a good solution. So in this case, you can get the same behavior for different classes that have no relation with each other at all. So that is why we are using interfaces. Does that make sense? Yeah?
So because with virtual, you can only use it between parent-child classes.
Okay, any question, guys? Yeah? So that is the iPay interface.
And if you have abstract class and abstract methods, that is also parent-child relationship.
Can you show your base on this one?
So the top or here?
we created this method inside the base class,
Mm-hmm.
and then we created the interface for this method, so we can't override it directly. So like,
Yes.
I mean, we would have to implement the interface, and then we can use those methods and override it.
That is correct. Yes.
So we're not gonna have to override it in each child class.
So you need to implement that in the classes that need to use that method only.
Yeah, and like if we don't need it, we're just not implementing it, and like not typing all this like public double will with the
Okay.
date. So we don't need it at all.
In the
It's not gonna give us error. Yeah.
So if you don't implement that, right? So I'll create another class actually for that one, the one that doesn't implement the interface, yeah? Right, so let me call this my volunteer, right? Okay, so this one does not get paid, is that right? Yeah, and we are going to inherit from the employee class. So what kind of information that the volunteers have? Volunteers have an ID, right?
Yes,
Yeah.
I do.
So still a name, and we can get the details of the volunteer, and the volunteer has to work in a department. Is that right?
Mhm.
Because these are all of the members that we inherit from the base class.
Mhm.
Now, does the volunteer get paid?
No.
No.
So we don't need to implement the interface like this one here, right? So if you need to get that payment to be calculated in the class, then that is what you need to do. Implement the interface. Otherwise, you don't need to. And that's it. So that is another example.
Where is there an error? It's
Yeah.
probably
Because you didn't implement that yet. So if you want to implement an interface, then you must write the implementation of the method. Right? So-
I see.
Easy way to do the quick actions again. So you can implement the interface, and then it's going to give you the syntax, and you just have to change that, right? So some people might say, okay, let's return 0 in that case. Yeah? But we don't want to do that in this case. So you don't have to implement that at all, and that's it.
As in, so every class
Mhm.
that implements every class that implements the interface
Mm-hmm.
will need a new definition of the method.
Yes, that is right.
That's
Yes.
what I want to
And
know. Thank you.
so when you say definition, that is the same as implementation,
That's
which is the same as body.
Yes, excellent.
Okay, that's
Yeah, makes sense?
kind of like
Yeah.
I'm seeing the logic.
Hmm. Okay, the interesting part actually, guys, what we're looking at here is what we call as object-oriented design. So how do we design the solution in object-oriented way? Are we using classes with inheritance, base class subclasses? Are we using interfaces in our solutions? And what kind of relationship that we have between the classes, such as aggregation, composition? Because for the same task, I can actually design this differently. Maybe I have one class without multiple classes, and I can still get the same result. But it's going to have a different way to manage that. Because imagine that you have all the information in one class, right? I can create a generic employee class, and then this employee class has the ID, the name, the department, it has the hour work, the rate, and the annual wage as well. So everything that we need could be inside that class. Is that going to give me the same result? The answer is yes, but it's not a good design. Why is that not a good design? If we have everything in the same class, one class only.
You probably have a lot of repeated code.
Yeah.
We're also gonna like keep in memory all this
Very good.
useless information.
Yes. So every time you define the fields in the class, right? What happens when you create the object of that class? It reserves the space in the memory for every single field that you define. So if you have 10 fields, and let's say they're all integers, right? So you're going to do 32-bit times 10, and that is how much space that you reserve in the memory, right? But if the class only have 2 integer fields, and you're just going to use 32 times 2. And that is the difference. Do we really need to have all those fields in one class? So one place that you need to think about is the memory, right? And then another thing you need to think again is about reusability. So if you create one class to solve this task, you're going to define all of the members in one class. So your class is going to be really, really, really long, right? So you have a lot of definitions. Now, if I want to create another class that has similar behavior, usually what we do inheritance. Is that right? But if you inherit from this class, you're going to inherit everything from that one class. Is that something that we want? Is that going to create another problem? So is it easy to maintain? So there are a few things that you have to consider there with object-oriented design, right? So it's easy to solve a task in programming. It's easy to write the code to get the same solution as someone else, but to have a good design is not that simple. Okay,
So
that is the
if you have an object
Yeah.
that has a lot of fields, then what is the problem? I don't see any problem with creating a base class with a lot of fields, and then having a child that inherits those many
Yeah,
fields. From
there's
the
no
parents.
problem with that as long as a highly cohesive class.
Okay, yeah.
Yeah.
Okay.
So the problem that I mentioned earlier, imagine that you have all the fields combined in one. So let's say in one class, I have these fields, so ID, name, and then I have department ID, department name, right? And then I have, notice that I have annual wage as well. And then I have the hours and the rate. So imagine one class have all of those fields, right? So that is not highly cohesive at all. And it's really hard to maintain. And every time you create the object of the class, it's always going to create all of those objects in the memory, so reserve the space in the memory, but you're not using all of them. Because depending on the type of the employee again, you may not have to set the hours. But again, sometimes you do, right? So if that is the case, that is not a good design. We don't want that. Yeah? Okay. Does that make sense, guys?
Is there also a general principle about how many layers of inheritance is good?
Not really. So look at the classes in our class library. So let's say we want to look at stream reader. Remember stream reader? Yeah? Okay. So how many level of inheritance? Have a look here. So stream reader inherits from text reader. Text reader inherits from this class, and then that class inherits from object. So these are the 4 levels.
Oh, that's really
right?
cool.
But there could be different number of levels for each class as well. So every single class will always inherit from object. Always. Alright, so what's in the object class? Have you looked at the object class? What are the members? So look at the methods here. These are the methods of the object class. Yeah, so let me take you to the methods, and then you can see these methods that can be overridden by the subclasses. So when you create a class and you inherit from the object class, right? So as every single class actually does, then you can override any of these methods or all of them because you inherit them from the object class. So we can override the toString method, we can override the getHashCode, finalize, and equals. Now, some of the methods here, they cannot be overridden. So only these 4 that can be overridden. Okay, so object class, they do not have too many methods even, because that is going to be the base of every single thing, right? So you need to try to apply the same principle when you create a base class. So just put the necessary members, do not try to add too many. Alright, so how are we going with that? Yeah. Alright, any other question?
I think it would be really helpful if we have time later on or next week to on Friday to go through the
aggregation. Yeah. Mhm.
Example with it, because there are so many different parts.
So every single class, every time we are not working on something specific, it will be object-oriented design.
Yes.
So we'll be doing that from now on. Because this is all about designing. It's not really about writing the code, which you already know.
Hopefully.
Alright, so are we okay? Yeah?
Trying to be okay.
Trying to be okay. Alright. So guys, just to let you know about the rest of the topics here. Now, one of the questions that you have is about the UML diagrams. So I have a few references here for you. And also, if you have a look here, we have one extra reference that will take you to the whole different type of UML diagrams. So there are two different websites that I use. So one is the UML diagrams, and then the second one is the visual paradigm. So most of the time, you can find good examples and good explanation about UML diagrams. Now, let's have a look at one of the references here, and then we are going to just briefly look at the other ones as well. So there are different types of diagrams that you have to describe in your knowledge assessment. You need to describe class diagram, activity diagram, state machine, and sequence, then communication. So these are the different type of diagrams that you need to describe in the knowledge assessment. Now, so I'm going to take you to the first reference, and I'm also going to take you to the next one here. Okay, so there are two main references. So the first one again is the overview of UML diagram. Okay, so what is UML diagram? So have a look at this part here. The purpose of UML diagram is actually to model your system. So we are going to create the design of the system by creating the diagrams. So it's a visual representation of your system before you implement that. So that is basically the purpose of UML diagram. Now, if you have a look on the top here, there are many different types of UML diagrams. So we have classifications of UML diagram. The UML diagrams can be divided into two different categories. So we have a structure diagram and we have behavior diagram. So on the left hand side, these are all the different structural diagrams. On the right hand side, all the different behavior diagrams, right? So what do we mean by structure diagram? Structure diagram only shows the static structure of the system. So for example, it shows you how many classes that we need in order to define the solution for the system. So that kind of diagrams that shows the classes is one of the structure diagram called class diagram. And that is the first one that you're going to see. Now, why do we have to learn about UML? Because before we start writing the code, we usually want to start designing the solution first. So this is a design tool in order to visually see what kind of solutions that you're going to implement later on. So behavior diagram is to show the dynamic behavior of the objects in the system. That could be showing interaction between the objects or how the user uses the system and so on. So that is the behavior of the items within the system. So one of these is called activity diagram. So that is another one that we are going to look at today. So that's basically the two different categories of UML diagrams. And again, you can click on the link on the top here to go to each one. Yeah. Now, I put the direct link for each one of them. So if you have a look here, we have the link for the class diagram, activity diagram, and so on. And we also have another reference from the visual paradigm website. And these also have a good example and explanation about UML. Now, I'm not really going to read from all of these pages, but I want to show you again all the different examples about different type of diagrams. And again, we can see the two types of UML. So we have structure and behavior, and each of these have multiple diagrams. All right, so what is a class diagram? So I'll go to this one here. So the class diagram is a structure diagram that shows the structure of the system at the level of classes and interfaces. So you want to create the classes in the UML class diagram. So how do we design the classes? we start by creating the rectangles, and then the rectangles can have multiple parts. The first part is the name of the class. So how many classes we need in this solution? For example, the system needs these classes. We have a book class, we have an item class, we have an author class, account, and so on. And you can describe all of the fields that we need to define in the class as well. So what kind of information that we want to store. And if you want, you can add the methods as well in the lower level of the class diagram. So you have more details added to the diagram. Now, when you create your design is something that doesn't become final straight away. So you're going to create the first version of your design, and then you're probably going to discuss that with your teammates, and then you come back to change the design slightly, and then go back to revise that again. So when we talk about design is something that can change, but when you create your design using UML diagrams, you need to know the notations. The notation do not change. So for example, if I want to create a class diagram, it has to be a rectangle, and it has to have the name of the class on the top. So you cannot just create, let's say, an oval, because it doesn't have the same meaning in this type of diagram, right? So notations stay the same, but your diagrams can change over time. Now, another thing that you can see, besides the class information, you can see the relationship between the classes as well. So if there are any relationship like aggregation, composition, inheritance, then you create a line between them. And then you can add different symbols depending on the type of the relationship. Remember again, I'm not going to talk in details about how to create each one of them, because that's what we're going to do next week. Because what you need to do in the project assessment, you need to create the diagrams. So you have to understand what notations to use, and then how to define one yourself, right? So today's class is only the introduction to tell you what they are, and then when do we need to use them, right? Okay, so that is about the class diagram. And then the next one that you see here, so let me just take you back to this reference, is about activity diagrams. So activity diagram is one of the behavior diagrams. So let me take you to this example first. Okay. So what is the purpose of activity diagrams? We want to show the flow of control, or the object flow, with the emphasis on the sequence and conditions of the flow. So when we talk about activity diagram, we are showing the activities in the system. So the activities will be the processes that are happening in the system. So for example, have a look at this example here. Probably I'm going to take you to another example that is more complete. So activity examples, and have a look at one of them. Okay, so which one do we want to look at? The easy one, maybe? First one. Okay. So this is an activity diagram example for an online shopping system. Now, what can we see here? So the notations again are really important. So we have the start node, we have the end node. So the start is the black circle on the top, and then the end node has the white border surrounding that. Now, what do we have here? It's going to show the flow of all the activities inside the system. So when you start the system from here, the start node, then it's going to go to decision. So what kind of options do we have? We can perform search, or we can browse for items. So these are the two flows that come out from this one node here. So that means we have options, and then the search will take you into the search item process, and then it's going to give you two results, whether we can find the item we're looking for, or we cannot find the item we're looking for. So if we cannot find the item, then it will go back again to the beginning search page, and then you can do further search. So that is basically the processes that involve in searching. And then we also have the browse. So that is another process in the system. And then you can see all the different activities for each one. Now, the idea again of this is basically to show you what kind of activities or processes required in order to perform a task. Or it could be how the system works overall. So, for example, if the system requires the user to log in first, so the first thing that you will see here is going to be the login process, right? So the user have to log in, and then what will happen then? The next activity is to verify that. So you're going to check if the login is valid or invalid, right? And if that is valid, then it goes to another process that maybe will take the user to display some information about themselves. So it takes them to the profile page and so on. Or if the login is invalid, it might go back again to the part where it asks for the login details. So that is just to show you whole processes about the system or for a specific part of the system. Now, there are more examples again from here. So I'm going to show you another example here. Activity diagram example. So that is an activity diagram. And this example, let's have a look at the description. So what do we want to show here? Okay. Is there any description? So we have an author and we have the moderator. Okay. So that is basically about a system where the author is going to publish a book, right? So what are all the processes required or all the activities required? So we need to open the article first and then publish, and then it goes to the next operation to moderate that. And then it has the option here where it can be set to publish or it can be rejected. Now, the only thing that is different this time, you have the authors as well. So the role of the users on the left-hand side here. So that means the system can be used by two different roles. We have the author on the top, and then we have moderator at the bottom. So that is just a different notation. So sometimes your activity diagram could be just about the whole flow without any role at all in the system. But sometimes you want to make it really clear about which type of role that can perform a specific task. So that is when you create this kind of notation in the solution. So sometimes you have options in order to create the diagram. Now, so that is just to show you again another example. How are we going so far?
So the purpose of it is so that it so you can have roles, you can have roles for specific tasks and the order.
That is right, the order. I like that keyword because that is what you see here in activity diagram. So the order of all the processes required in the system, right? Excellent. Right, so if you think about your login application, right? So think about the processes of the login application. So what is the first thing that will happen first? So imagine that you have to draw the diagram. What is in the first bubble here? What would you say?
The computer shows a menu.
Very good. So display menu. That is going to be the first process, right? And then what happens after that? What will be the next one here?
User puts in an input.
Yeah, okay. So if you start thinking about the whole steps, you can think about in the bigger picture first, that is in a very high level kind of design, or you can go to the lower level with a lot of details, right? So activity diagram is basically a flow chart. It shows you all the different steps. So do you want to make the steps to be just very generic to start with? And then later on, you can expand each of these parts of the system. Or you can make it really detailed. So for example, I'll give you two different levels, right? So you display the menu, and then what happens after that? So after you display the menu, in the higher level, you can say, we validate the login. But we don't say how to validate the login. Is that right?
Yeah.
So then if you want to do this in the lower level, after you display the menu, and then you get the inputs, the username, password from the user, and then you say the next process is to read the valid data first from the text file, and then the next process after that is to compare the two values. So that is the lower level with a lot of details, right? So usually when we start creating the diagrams, we start with the higher level, and then we expand that into lower level. So remember again, diagrams can change over time. So we make it into a very generic kind of diagram first, so you can share that with your teammates and then discuss the main features that needs to be implemented. And then your team might say, oh, I think we're forgetting one part of this, so maybe the validation needs to be done as well. Or maybe you're forgetting to print the result at the end. So then you start modifying your activity diagram to include those features as well. And then after that, you can expand each of the feature. So how do we print some information? So that part can be expanded using activity diagram, right? So that is basically to show the processes. So what kind of processes that we have in the system. Right, so everyone okay with activity and class? Yeah, so you can see the class here as well, just very quickly. So that is an example of the class diagram. So we have customer class with the 2 subclasses, and then we have the order class, and that has relationship with the order line, and then product as well. So this is what the class diagram looks like. Now, so next one. So let's have a look at the next one, state machine diagrams. So what is the purpose of that? So let's have a look at that one. Okay, so back to this first, and then back to UML, and then my state machines. Okay, now, so state machine is a behavior diagram again that shows you the different states of your object. So what are the different states of your object or the different state of the system? This is an example. If you want to describe the state of a bank ATM, so the bank ATM can start with the idle state. So that means no customer is using that ATM yet. And then when the customer insert or press a key on the keypad, that is going to become active state. And then once we finish using the machine, it can go back to the idle state, right? So that is basically the main states that you have in the ATM. But every now and then, maybe we cannot disperse more nodes because we run out of the nodes. So in that case, it goes to out of service state. So that is just to show you the changes in the states. Now, another example this time from the other reference, so state machine. So this is the example of the states of a phone call. So what happens first? You're going to start with the dialing state, and then calling state, and then call receive. And then after that, in talk. So when someone picks up the call, and then that is in the in talk state, and then after you finish talking, it could be in the call terminated state. And then that is the end of that. So that is just to show you all the different states. Now, when you create state machine diagram, you can use that to describe the state of the system. So let's say your system could be, a very big system with different states, like the bank ATM system, right? Or you can talk about the state of a specific object in the system. So for example, imagine if you create your ICT-PRG project using object-oriented way, right? So your login application. You might have a login object that has different states. So the login object could be in the valid state or invalid state. Or you can say initial state, because we haven't actually done the validation yet. So you create the login object, and that is in the initial state. And then you perform validation, and then that could change into a valid state or invalid state. And then after that, it ends, because that is the end of your object states. Nothing else will happen after that. So it doesn't change that into something else. Or you can say, what if my invalid object can be revalidated again? So then it can go back to a valid state. So there could be iteration in this case. So that is similar to this example here. So if you look at the iteration, right? So it could be idle state and then becomes active, and then after that it goes back to the idle state. So the states could change, and what you need to show is how do they change. And that's basically the state machine diagram. You need to show the changes in the state. Or you can say another example is account object in the bank. So let's say you start your account object, and that is your, initial state, right? And then when you put more money, you're going to become a gold member. So you're going to have a different state in your account. So let's say your state is gold state. And then one day you withdraw all the money, right? So what will happen? Maybe it goes into a different state after that. So it becomes, let's say, a bronze state. So you're not in the gold state anymore when you don't have any more money left. And what if you over withdraw from your account? So let's say you're allowed to do that. So your account object could change into a red state or a warning state. So that could be again different type of states for specific objects in the system. Now, so that is basically your state machine diagram to show different states, either of the system or the objects within the system. Make sense? Yeah? Okay. Alright, so if I ask you about the state of student enrollment, what do you think?
Student enrollment.
Enrolled.
Unenrolled.
Yeah?
Enrolled.
Enrolled and then inactive.
Yeah, what else?
And enrolled.
Yeah?
Like active and active dropouts.
Withdraw?
Or withdraw.
Yeah.
Yeah.
Then complete. So you finish your enrollment.
The
So that
score.
means you finish the course, right?
Oh, okay.
Yeah. So think about all of those different states. How does that change? So for example, when you type in your details on a state website, right? And then you click save, you haven't really submitted that yet. It could be created in the system. So that is a pending state. That is your enrollment object in the pending state. And then when you click submit button, then it's going to send that and it's going to be verified, right? So that pending state could become two different states. Let's say confirmed or rejected, for example, right? And then from the confirmed state, what will happen? You can go to two different states again. So confirmed state, let's say, could become active, or that could become unpaid because we haven't paid that yet. And then what happens after that? They can go to different states again. So let's say complete or withdraw, right? So these are all the different states of the enrollment. So that can be shown in the system machine diagram. So how do they change? All right, so that is basically one of the diagrams that you have to describe. All right, are we okay with that one? Yeah? Okay, so two more to go, guys. So sequence diagram and communication. Now, for the last two here, they actually represent the same kind of information, but using different notation. So I'm going to show them both, and then we'll have to look at the different notation. Alright, so back again, and then let's have a look at our sequence diagram and then communication, right? So what is the purpose of this? Have a look at the first statement. So it's the most common kind of interaction diagram that focuses on the messages. So the message that we exchange between the objects in the system. So that is basically about the object's messages. So what kind of message that one object will send to another, and what kind of message that will be sent from this other object to another object. So that will be all the different messages. Now, when we talk about messages in object-oriented programming, there are methods. So you're calling methods of the object. So that is what you're going to show here. So this is an example of sequence diagram. So focus on the objects and then look at the methods. So we call the validate method from the window object to the comments object here. So this is the method that we call. And then after that is going to create, let's say, an object called proxy. And then this is going to perform the AJAX operation and then returns the object. So don't worry too much about the details, but I want you to focus on the notation. So what you see here, inside the big boxes, they're the objects. So then we have different type of objects that work together. And the line between them with the arrows, that will be showing the messages. So what kind of methods that we are going to call from this object to the next object. Now, look at another example in here.
So it talks about objects or methods. Which objects and how methods are used to interact with objects?
So,
or is it just methods to methods?
yeah, so objects interaction is through method
Or
calls.
methods, yeah.
Right, so that is another example for sequence diagram. So this is actually a high level sequence diagram. So it doesn't show all the objects within the system, but what kind of messages that will be sent from the user to the system. So in a very high level, it will look like that. So you have a message to click on this item here. And then it's going to return the order form. And then after that, the next message is going to be selecting some information, and then you have to select agree option. And then the next message you could click next. So what you're looking at here is slightly different from the previous example, but the notations, they stay the same. You can see the boxes, and that represents an object or the item of your system, right? And then you can see the lines that shows the direction of the message, and you can see the label of the line that talks about what kind of message that you want to send. So that is basically still the same, but in a very high level. Okay, so I think we have other examples that we can see here as well. So let's look at other examples for sequence diagram. So that is again another high level one. It's a bit blurry, guys, sorry. Oh, I cannot dismiss that. Alright, so let me just put that on the side here. Okay, so that is again the customer, which is the user of the system, and then this is your system itself, right? So what kind of messages that we have here? So we can search for inventory, and then the system can return the results of the search operation, and then you can view the book description, you can add the shopping cart, and so on. So these are all the messages in the high level. Or if you want to look at the lower level, we have other example like this one here. So this is the example in lower level. It's interesting, the image is actually really bad quality here, so you cannot see that properly. Maybe I can click on that. Hang on. Yep, that's better. Alright, can everyone see that? Yeah? So that is another example of sequence diagram. So what do we see on the top here? Objects. So we have web browser instance, application instance, and then Facebook authorization server, and then the content server. So you're sending a message from the user to the web browser in order to get resources, and then that message is going to be sent to the application. And then the application is going to return the HTTP redirect, and then the next message is the authorize, and then you're going to return the permission. So that's basically the whole process.
Why is this a low? Why did you refer this to a low?
Because you show it's not really low as in the previous example, because we're showing the interaction between the systems.
Okay.
Yeah? So it's still quite high level, but you have more details in this case.
Yeah.
So it's not just about how the user get the end result by interacting with one system. So this is a lower level compared to the first one with only two items.
Okay.
The user and then one system, right?
Okay.
It has a bit more details, but it's not really low level because it doesn't talk about how the objects in the application will send message to each other, right? So again, so many different levels that you can write. Now, so just keep in mind the notations is really important, and what you need to know at this stage is basically the description. So what is sequence diagram, and then how do we use that? So what is the purpose of that? So that is the main thing that you need to know. Now, so remember when we talk about how the messages are sent to each other? So communication diagram actually has the same purpose. So I'm going to show you the communication here. So back again, and then let's look at the communication diagrams. So what is the purpose of that? So the diagram here is also an interaction diagram that shows the interaction between objects or parts of your system. Now, so if you look at this, so this is your sequence diagram, is that right? So that is the same as what we saw before, sequence, and that can be represented as communication as well. Alright, so where is that? Communication is one here. So this is the communication diagram. Very similar to the system diagram that we saw earlier, but what is the difference? What's the similarities first? Look at the boxes here.
The boxes represent objects.
Very good. So we can see the objects or the system, right? And then we can see the messages that we send to each other as well. So between the systems or between the objects. Now, the difference this time, you don't really see the sequence as much. But in order to indicate the sequence, you can add the numbers for each of the message. So you can put 1.1, for example, and then 1.2 for the next message that will be sent after that one. And then you can add the numbers for the following as well. So this information is the same as what you see in the sequence diagram, but using different notation. And that's basically it. So you can see the example here. So let's say I'm going to look at communication diagram, right? So we have different systems or different objects and the messages between them. Alright, so that's all about the UML that we need to know. And then, actually, let me just give you a copy of my, where is that again? I think I closed that before. So C# interface. Okay. So I'm going to update the reference in your P drive. And let me just make sure that is the updated one. Alright, so Tuesday, and then reference, and then let me just add one more thing here. So that is the reference to the interface in C#. Alright, so guys, so once you finish with all of those topics, have a look here. So the topics that we covered today, they're basically for these questions in Knowledge 1. So question 10 to 12 and 14. Now, if you look at all the questions that I asked you to do for homework, this cover everything in Knowledge 1 now. So that includes reusable component that you learned on Friday. And then today, we learn about UML and object-oriented design. And then all the other questions that we discussed last week, right? So that means you should be able to submit the document, the completed document, by next Tuesday. So Friday, I'm going to quickly get you to go through each of the questions again. So just make sure